All right, so when last we were together, we were looking at the unit circle. And this is going to be important for a lot of what we do today with the unit circle and what we do kind of for the rest of the trigonometry unit and the rest of the next trigonometry unit. So by definition, what the unit circle is a circle with a radius of 1 centered at the origin. So you can see a diagram here. You can see one up there as well. The important thing to remember here is that on the unit circle, the relationship between the x and the y coordinates of any point is just the Pythagorean relationship. It's x squared plus y squared equals r squared, but since the radius of the unit circle is 1, it's x squared plus y squared equals 1. So if you know x, you can always find y. If you know y, you can always find x. What this culminated in, what the kind of conclusion was at the end of building this big beast, which you might have in front of you on that sheet of paper. There's no seminar today. You bet. What it culminated in is the realization that on the unit circle, if you take the cosine of the rotation angle, that will be the x coordinate. And if you take the sine of the rotation angle, that will be the y coordinate. And you need to know, again, I mentioned on Thursday, there's ways to kind of maneuver your way around this. But I would say if you do know the coordinates of all of the points that we talked about on the unit circle, then you are at a huge advantage compared to not knowing those coordinates. You look at this, and it's like hitting a brick wall. There's an awful lot of information there. But I don't think your best approach is to memorize things. Okay, I really don't. It's called the unit circle, which means the radius is 1. There are certain things that your memory is going to help you with. For example, I do believe it's kind of, I guess, a good idea to memorize these coordinates. To know that on the unit circle in quadrant 1, when you get to that location where the x coordinate and the y coordinate have found a balance at 45 degrees, I think it's important for you to know that's root 2 over 2, comma, root 2 over 2. Remember, please, that root 2 over 2 is the same as 1 over root 2. Right, let me write that down. Root 2 over 2 is equal to 1 over root 2. There's no mathematical difference between those two statements. They just have different masks on. They just have different disguises. Okay, they're equal to the same number. If you can then remember that I call them the oddball positions, the ones that are closer to the axes but not on the axis. So anything that's 30 degrees away from the x-axis or 60 degrees away from the x-axis. That those two coordinates are always a half and root 3 over 2. And if you can figure out which one is a half, then the other one is root 3 over 2. Which one is a half is pretty easy because all you do is you look at, say, the y coordinate of this point, and you ask yourself, is that 1/2? And there's no way that that's 1/2 because the distance from the origin to the y-intercept is 1 because it's the unit circle with a radius of 1. And that is definitely not a half. Whereas if you were to look over here at this y coordinate, that y coordinate is definitely, well, I mean, we don't have to get out the drafting tools here and AutoCAD to figure this out. We know that one of these coordinates is a half, and that looks pretty close to a half. So the other one is root 3 over 2. I mean, the other thing you can do is you can go in decimal form. So if you indulge me and take your calculator right now, I mean, we know what 1 divided by 2 is. It's 0.5, right? But what's root 2 divided by 2? About 0.7, isn't it? 0.707. What's root 3 divided by 2? Pretty close to 0.9, isn't it? 0.866. So you can kind of see what's happening here. There's your 0.5 for a y coordinate. Here's your approximately 0.707. Here's your very approximately 0.85 or 0.9. So you can see the y coordinate goes from 1/2 to √2/2 to √3/2. It's a nice numerical pattern. I also pointed out to you that you could write 1/2 as √1/2. So then the y coordinate, looking at the y coordinates, goes from √1/2 to √2/2 to √3/2 to even, you could say, √4/2. And down here, you could say for the 0, √0/2. So these numbers form a very pleasing mathematical pattern: √0/2, √1/2, √2/2, √3/2, √4/2. It's a nice pattern. And what you ideally want to be able to do then is take that information and transfer it to any quadrant. Now, when we did this in class, I talked about flipping those numbers around and moving them from quadrant to quadrant. I don't think that's what you need to do. If, for example, you wanted to investigate things in quadrant 3 and you didn't know any of them, there is no reason that you need to do quadrant 1 to figure out quadrant 3. There really isn't. The only thing that you're going to do is remember that in quadrant 3, both x and y are negative. So you start off with the 45-degree mark, which is 5 pi over 4. And you say, well, that's √2/2, √2/2. Or I'll use the 1 over √2 this time. Then you pick one of these points and you say, well, I don't know, is the y coordinate, that's the x coordinate, by the way, is the y coordinate the half of the radius, or is it the x coordinate? I think it's quite clear that it's the y coordinate. So that would mean that the y coordinate is negative 1/2. What does that make the x coordinate? Negative √3/2. Because, 1/2 and √3/2 go together like PB and J. They have to go together. Down here, you can see that this is 1/2 in terms of a distance, so the x coordinate is negative 1/2. The y coordinate would be negative √3/2. And by the way, the two quadrantal points, where am I? The two quadrantal points, you should know that they always involve zeros and ones. So that's why you end up with all of these numbers. All that being said, there are the 4 quadrants. Does anybody have any questions? Take a look, because it's been a few days at your work, and see if you have any questions you would like me to go over. Go ahead, Liam. H? So what are we asked? We're asked for the coordinates of the point on the unit circle, excuse me, and you're asking about this one. Okay. So P of 5 pi over 2. The first thing that you want to do when we're talking about rotation angles is make sure you're aware that there's a difference between, they're connected, but there's a difference between an angle and a location. Okay, the angle is a road map to get you to a specific place or location, and it's wherever the terminal arm is. Now, 5 pi over 2, in my mind, I think of that as 5 pi over 2, and my mind immediately then says pi over 2 is a 90-degree slice. So when we look at 5 pi over 2, it's 1, 2, 3, 4, 5 pi over 2 is here. And since I'm doing this on a video, I guess I should indicate that here. This is 1, 2, 3, 4, 5 pi over 2 is this location. So there's a terminal arm there, and that terminal arm continues forever, but it's intersecting the unit circle. So it's intersecting a point on the unit circle, and on the unit circle the radius is 1, which tells us that the y coordinate of that point, since it's on the y-axis, will be 1, and the x coordinate is 0. Does that make sense? Other questions? 3C? Okay. So determine the missing coordinate for a point on the unit circle if this is the point and the point lies in quadrant 3. So we have to use the idea that x squared plus y squared equals 1 on the unit circle. Oops, I just passed it. So x squared plus y squared is equal to 1. We could say in a more general sense, and this will be important for later today, that x squared plus y squared equals r squared, but since we're dealing with the unit circle, it says unit circle in the question, r is 1, and r squared is 1 squared, which is 1. So that's going to be our first step, is to say that x squared plus y squared is equal to 1. So I'm going to put in the x coordinate. I guess I'm going to go with what I told you, is always put brackets around things that are being squared. So I'm even going to put it around the y, but that's really unimportant. The important thing here, Ryan and everybody, is that when you square this 7/8, it's going to become positive. And I would want you not to just go 7 divided by 8 in your calculator and look at 0.875 and then square it and get this long decimal. I would expect you to be able to figure out that -7 quantity squared is 49 over 64. And honestly, everybody, if you have to use your calculator to square -7, that's okay. But I would rather you do that and square 8 and write 49 over 64. Okay. This is equal to, this is plus y squared equals 1. So y squared will be equal to 1 minus 49 64ths. Now 1 is 64 64ths. Okay, so I'm just converting to a common denominator here. And if I had 49 kittens and I if I had 64 kittens and I subtracted 49 kittens, other than being a little sadder because of the loss of the kittens out of my life, I think I'd be left with 15. How's my subtraction? Is that right? So if I had 64 64ths and I'm subtracting 49 64ths, I'm going to get 15 64ths. And now you're into, even though this might look like a grade 8, 9, 10 question, it's a grade 11 problem at this point. Because when you take the square root, you have to recognize that it's plus or minus the square root of that 15 64ths. And the square root of 15 is the square root of 15. There's nothing you can really do with that. You could write it as a decimal, but then you lose the exactness of the value. You understand what I mean, Ryan? Okay. Because it's irrational. Root 15 is not rational. But 64 is a perfect square, so the square root of 64 is 8. So now you have a decision to make. When we read that, we say plus or minus root 15 over 8. And that literally translates to this. Now, we don't teach logic in the -1 stream, but the word or doesn't necessarily mean just one or the other. It could be both. That's what the word or in mathematics means. In this case, though, it does definitely mean only one. It's not this one because I believe in the question it said quadrant 3. Did it say quadrant 3? So we know that in quadrant 3, I don't need to pull it up on the side monitor here, but when you look in quadrant 3, that's down here, x and y are both negative. Okay. So that is the missing y coordinate. Is that okay? Okay. Any other questions before we move on today? Yeah, Julie. 6? Perfect. So determine one positive and one negative measure for that point. So the first thing I'm going to do is notice that there's a number of a half there. And that's going to be my way to locate the position, not the angle, the position. So I'm simply going to sketch a circle and, mathematical tools that you were allowed for exams are rulers and protractors to measure angles. You're not allowed a mathematical tool like a compass to draw a circle, but you're allowed to write your exam with a cup of coffee, right? With a paper cup of coffee from wherever, Tim Hortons. So, I really recommend having something that's by your side in the diploma exam where you can draw a nice circle. Because I can draw a pretty decent circle freehand, but freehand for a lot of people, it doesn't work out that good. And it's important that you draw it fairly well, because then it will make your life a little bit easier in locating the points. So the y coordinate is a half. That's this point right here. So that's telling us it is either this location or this location. And now I have a visual here, Julie and everybody, that the position is one of those ones that's 30 degrees up from the x-axis. But you're also told that the y coordinate is negative. Sorry, the x coordinate is negative. So that tells you it has to be over here. This is the point that has a y coordinate of a half with the corresponding root 3 over 2 being negative. So the question is now asking you, if this is the terminal arm, what are two different ways to get there? When I say what are two different measures or possible measures for theta, I'm saying how can you get there? And one of the ways I can get there is to go 1, 2, 3, 4, 5 pi over 6. I could continue in this fashion and say 6 pi over 6, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6, 13, 14, 15, 16. I could say 17 pi over 6. How many of you are able to, these are coterminal angles, how many of you are able to come up with 17 pi over 6 from 5 pi over 6 without doing that counting thing all the way around? What we're doing is we're adding 2 pi, a full revolution, and 2 pi is 12 pi over 6. So I could have just added 12 pi over 6 to this. On the other hand, Julie, we could start here and we could say -1, -2, -3, -4, -5, -6, -7 pi over 6. Is that helpful? Okay. All right, let's move on. We're going to be looking here at the next lesson in your unit handout. So you'll need to open up your books to that page. Ryan, is that page 9? 10? 10. So we're going to be doing a little bit of review here from Math 20-1. But then we're going to introduce something which is not from 20-1. So we're going to have to, look at this, write the 6 trigonometric ratios for a point. It doesn't say it's a point on the unit circle. It just says a point, the unit circle. And then we'll do it with non-unit circles. But 6, sine, cosine, tangent, but there's 6. Whoops. There's actually 6 different trigonometric ratios, not just 3. And you haven't been told about those other 3 before. And we're going to get to that today. We're going to have to, it's one of the rare cases where I'm going to say we're going to use a calculator to find trigonometric ratios. And that's going to be whether we're in degrees or radians. Determine the exact values of trigonometric ratios for any of those common angles that we've been talking about for the past couple of classes. And then the very first bullet here says find all of the trig ratios for a point that is the intersection of a terminal arm and the unit circle. This is just saying you should be able to do it on non-unit circles where the radius is not 1. That's all. And then finally, if you know one of the trigonometric ratios, you should be able to determine the other 5. Everything we are doing here really actually is from 20-1. The only difference is we've got 3 more trig ratios. So however we find these 5 trigonometric ratios, that's how you did the problems in Math 20 to find the other 2. Okay, so a review from Math 20 is that on a coordinate grid, a rotation angle has a cosine, a sine, and a tangent ratio given by the ratios of x's and y's and r's. In Math 20, this was given on your formula sheet. It's not on your formula sheet in 30. You need to remember this. If you put, just talking about cosine and sine, if you put cosine and sine, those words in alphabetical order, they match up with the same alphabetical order as x and y. Somehow you have to remember that tangent is y over x. This all goes back, by the way, to the fact that if you draw a triangle on here, R is like your hypotenuse, X is like your adjacent, and Y is like your opposite. So it's SOHCAHTOA translated to a different language. I noticed as I was preparing this lesson to this morning that I don't actually have this that's highlighted in your notes. You should know it, and if you need to write it down, you can write it down, but you should know x plus y squared equals r squared. So now, what about these three trigonometric ratios that are new to you? They're called the reciprocal trig ratio. A reciprocal means 1 divided by. So the reason why the reciprocal of 3/4 is 4/3 is 1 divided by 3/4 gives you 4/3. That's what the word reciprocal means mathematically. So each of the three primary trig ratios, sine, cosine, and tangent of an angle, have a corresponding reciprocal trig ratio. And the reciprocal of cosine is called secant. The reciprocal of sine is called cosecant, and the reciprocal of tangent is called cotangent. So this right here, this SEC theta, means the secant of theta. Come on. It means the secant of theta. CSC is the cosecant of theta. COT is the cotangent of theta. Now, we abbreviate things when we say them, okay? So very often we will say cos theta. And sometimes I get a little sloppy and I just say cos. That's probably, I bet the is cosine of theta. So if I say cos, it should be cos theta. We don't really abbreviate this. We abbreviate it when we write it out, but when we say sine theta. We don't pronounce it sin theta. We do abbreviate this verbally. We say tan of theta. So what are the corresponding abbreviations here? There isn't one here. I've never heard anybody say sec theta. It's secant theta. You don't abbreviate it verbally. Same with this, cosecant theta. We don't abbreviate what comes out of our mouth. This we do abbreviate sometimes. It's called cotan theta. And although these are on your formula sheet, these three things, I want you to notice that in each pair, there's one co. I hope it makes sense that tangent and cotangent go together, right? The tangent is right there. So which one goes with cosine? Secant. Because if cosecant went with cosine, there'd be two cos. And I'm telling you, you can just remember there's a co in each pair. If you're looking for where they are on your formula sheet, when you look at your formula sheet, we've already covered the theta equals a over r. There's a couple of other formulas here that we'll talk about later this week, but your three reciprocal statements are there. So although you don't need to memorize the whole XYR thing, or you do need to memorize that rather, you don't need to memorize these. Okay, so what does this mean? If we tie this together with Math 20, if you look at this line right here, the top line in this box, we have cosine of theta equals x over r, sine of theta equals y over r, tan of theta equals y over x. We memorize these. So how do we calculate something like cotan of theta? Well, tan of theta is y over r, over x. Tan of theta is that. So cotan of theta is the other way around. It's x over y. Are you with me on that? So if you know that cosine is x over r, and I say what is secant, you go to your formula sheet. You see secant is the reciprocal of cos. You say cos is x over r, so secant of theta is r over x. None of these are on your formula sheet. None of these 6 statements that are really important are on your formula sheet, but you do need to know them. What if the point was on the unit circle? Think about that for a second. If the point that's on the terminal arm that we're using to find any of these ratios is on the unit circle, then r is 1, right? This is true for any rotation angle intersecting any circle. But if it's on the unit circle, these things become the following. I mean, just think about this. On the unit circle, cosine is x because cosine of theta is always x over r. But r on the unit circle is 1. This is the power of using the unit circle. You don't have to figure out what r is. So what is secant? Well, secant is the reciprocal of cosine. And if cosine is x, secant of theta on the unit circle is 1 over x. I really struggle every time I put together this unit, and after teaching the course, I always go back and try to make some changes, but I always struggle with, I want to just throw this out of the note package. Because this is subsumed by this, which means these 6 statements are already included in this thing. Because when r is 1, you can see what they become. So any questions with the 6 trigonometric ratios? All right, let's go to some questions. Not dealing directly with the 6 trigonometric ratios in terms of x, y, and r, we are asked here to determine the exact value of each of the following. Now, let's start off with maybe the easiest way to do this. For some of you, I mean, I know the answer is root 3 over 2 because I know my unit circle. Take your calculator in radian mode and take the sine of pi over 3. And you should be looking at, unless I'm totally mistaken, but I'm pretty sure you're looking at 0.866 something. Well, that's root 3 over 2. And hopefully you've memorized that. I'm showing you the kind of cheaty way to do this right now because I want to tell you that that cheaty way is going to let you down in the next unit. Okay? You will not be able to kind of get the answer on your calculator. So the better thing to do is to say pi over 3 is here. And when I look at a circular arc, that has an x coordinate of 1/2 and a y coordinate of root 3 over 2. And on the unit circle, sine is the y coordinate. It's root 3 over 2. Are you with me on that? Okay, so what about cosecant of negative 5 pi over 4? This goes to Liam's question from earlier, which has to do with if you know the angle, what's the location? Because I can't begin to tell you what the cosecant of that is unless I see where it is. So in terms of negative 5 pi over 4, pi over 4 is a 45-degree angle. So we're going in a negative direction. There's negative 1, negative 2, negative 3, negative 4. Negative 5 pi over 4 is there. So what is cosecant of this angle? Well, this has an x and a y coordinate, which we'll get to in a second. But this is on the unit circle. Right? We're looking at the unit circle here. We can get away with that. And I know that cosecant, I just learned from your standpoint that cosecant is the reciprocal of sine. Can you confirm that that's the case? Sine and cosecant are reciprocals of each other. They're the pair that go together. So my brain says sine of theta will be y. It's over r, but I'm using the unit circle because I'm familiar with the x and y coordinates on it, which means that cosecant of theta is the reciprocal of y. So we just need to know the y coordinate there. At that point, the numbers are negative root 2 over 2, root 2 over 2. So what is the cosecant? It's the reciprocal of the y coordinate, which is 2 over root 2. And that's the answer. Now, if you wanted to, we said 2 over root 2, correct? I could multiply the top and the bottom of this by root 2 to rationalize this and get 2 root 2 over this bottom part is root 2 times root 2, which is 2. Of course, what happens, might as well use every color I have now. What happens is the 2's cancel and you're left with root 2. You may have seen that quicker had you recognized that we could have said those were the coordinates. And when I take the reciprocal, I get a nicer number. I get root 2. Any questions with B? So as we work through these, what we are doing is we're imagining that it's a point on the unit circle, and we are using these definitions, remembering that on the unit circle, r is 1. So what about tan of negative 11 pi over 6? Well, you need to locate where negative 11 pi over 6 is, and I want everybody to take a minute and figure out, excuse me, figure out where on the unit circle negative 11 pi over 6 is. Again, the angle is what we use to figure out the location or the destination. That's not too good. That's not bad. Negative 11 pi over 6. So pi over 6s are little 30-degree chunks. This is 0. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many of you knew that that was the location? Because you know that 12 pi over 6 is all the way around, so 11 pi over 6 is just one wedge away. Okay, so what is the tangent? Well, the coordinates here are root 3 over 2, comma, a half. I can clearly see the y coordinate is the one that's the half. So tangent of theta is equal to y over x. So I'm going to take the y coordinate over the x coordinate. And I know everybody that most people, most teachers, most textbooks would tell you when you divide one fraction by another, you multiply by the reciprocal. Remember that rule? I want to just remind you that there's a better way to do this, because when things get more complicated in the next unit in particular, you won't be able to just multiply by the reciprocal. It gets way too complicated. So what you do instead is you say to yourself, my goal is to get rid of these little mini denominators. I don't like them. I don't want them. They're making things confusing. So I'm going to multiply the top and the bottom by 2. What happens is these two 2's cancel, these two 2's cancel, and you're left with 1 over root 3. Which, by the way, if you multiply 1 over root 3 by root 3 over 3, root 3 over root 3 rather, you end up with a root 3 on the top and a 3 on the bottom. So these mean the same thing. Well, just like root 2 over 2 is the same as 1 over root 2. Questions with that one? Cosecant of 3 pi over 2. So I'm not going to draw this one. Where is 3 pi over 2? If you look at my arms, 1 pi over 2 is at the top, 2 pi over 2 is over on the right-hand side, 3 pi over 2 is hanging straight down in between quadrant 3 and 4. So where it is here. That's the location of 3 pi over 2. Cosecant, let's see. Cosecant is the reciprocal of sine of theta, which is the y coordinate, on the unit circle, because that's what I'm using. And that means that cosecant will be the reciprocal of the y coordinate. Well, this is at 0, negative 1, which means this will be equal to 1 over negative 1, which is just negative 1. So if you go to Wolfram Alpha and you type in cosecant 3 pi over 2, it's going to tell you that it's equal to negative 1. By the way, you don't have a cosecant button on your calculator. And I'm not just hiding it from you. It isn't there. There isn't one. Cosine of 240. So where is 240 degrees on the unit circle? If you can answer that question, the answer to this question is the x coordinate at that point, because cosine is x on the unit circle. 240 degrees, let's see. 180 is here. 240 degrees will be another 60 degrees. So it's one of those, what I would call an oddball angle. It's not halfway between the quadrants. It's not a 45-degree chunk. That sure doesn't look like 1/2. That's going to be the negative root 3 over 2. That looks pretty close to 1/2. And of course, in quadrant 2, x is negative. And that means that, what were we after? Cosine? The answer is negative 1/2. You know, it's x over r, but on the unit circle, r is 1. Maybe I should address right now, why are we allowed to use the unit circle? Well, it's not just because I probably mentioned it in the question. It's because we know the x and y coordinates on the unit circle. If I said, do this with a circle of radius 2, you don't know the values of those coordinates. Although you could just double the ones from the unit circle. Secant of negative 45 degrees, negative 45 degrees is here with coordinates of root 2 over 2. I'm going to go with the 1 over root 2 this time. Negative 1 over root 2. Anybody know why I chose to go with this version of these numbers and not the root 2 over 2's? I did it because I'm asked for secant, which is a reciprocal of one of those numbers. And if I reciprocate root 2 over 2, I get 2 over root 2, which is right. But if I reciprocate 1 over root 2, I get root 2, which is simpler. It's nicer on the eyes. By the way, secant is the reciprocal of cosine. So I'm going to reciprocate the x coordinate, which is 1 over root 2. So this is root 2. I think you get the idea. So we are going to move on. We're not going to do G and H. Determine the approximate value of these things. So we're going to use our calculator. So you're going to take your calculator, make sure that you are in radian mode, and we're going to figure out what the cotangent of 7 pi over 8 is. So what does that mean? It means 1 over the tangent of 7 pi over 8. Listen carefully, everybody. It doesn't mean we're going to take 7 pi over 8 and flip it over or something. It means we're going to take the tangent of 7 pi over 8 and then take the reciprocal of it, because cotangent of theta is 1 over tangent of theta. So just make sure you're in the right mode, and I am. I'm going to take 1 divided by tan of 7 pi over 8. And you can see that what you get is negative 2.41 something. This is all just about how do you find a trigonometric ratio on your calculator when you don't have that button. We don't have a cotan button. How do you find the secant of negative 5 pi over 11? Well, you know from your formula sheet or from your memory that secant is the reciprocal of cos, so we're simply going to take 1 divided by cosine of negative 5 pi over 11. This is all just about learning how to use your calculator. That can't be right. And you get 7.03. What about the sine of 35 degrees? Well, I mean, geez, really? I don't even know why I put this in your notes. Sine of 35 degrees. Use your calculator and see what it's equal to. Oh, I know why I put it in there. And it's equal to 0.57 something. What about cos of 20? Can you figure out for me what cosine of 20 is? And I know what's going to happen here. Many of you will not get the answer I have, and you'll wonder, how did I get 0.408, which is the correct answer, and not 0.9 something probably, or 0.8 something, which is your answer. I put my calculator into radian mode. Right? I have to be in degree mode here for the sine of 35. I have to be in radian mode because there's no degree symbol. It's a bit of a trick question. So you have to put your calculator into radian mode and then go cos of 20. Are we okay with that question? All right. So now we're going to start getting into something that's more familiar to you. It's more like Math 20 and the trigonometry we did there. But before we do, let's take a look at this question. This point is on the terminal arm of a rotation angle. Show that that point is on the unit circle. This is a really good introductory mark in a written response question on a diploma exam. How can you show the marker that you know this point is on the unit circle? Well, if it's on the unit circle, then x squared plus y squared can give you only one answer, 1. So if we take x, which is negative 5/13, and square it, and add y, which is 12/13, and square it, what do we get? Do we get 1? Because if we do, it's on the unit circle. And I know that you want to go to your calculator, okay? But let's try to warm up that part of our brain that in the next unit with trigonometric rational expressions, your calculator doesn't help you at all. When we square a fraction, we square the numerator and denominator, and I believe the square of 13 is 169. You can use your calculator for that. I don't have a problem with that. I have a problem with you just putting everything into your calculator and going math, enter, enter. That's the issue I have. Plus 12 squared is 144 over 169. That means we have 25 plus 144 over 169, which is 169 over 169, which is 1. It's on the unit circle. We've shown that it is. And if this were a written response question, you would write that out. You would say, since x squared plus y squared gives us 1, that point is on the unit circle. The rest of this question is really quite simple. What are the values of the 6 trig ratios? Well, if it's on the unit circle, then r is 1. And that means that cosine is the x-coordinate, because r is 1. So the answer to the cosine is negative 5 over 13. Did I get it right? Was that the x-coordinate? It was. Thank you, Farhan. What is the sine of theta? Well, the sine of theta is the y-coordinate. Was it negative 12? Was it negative as well? It was just positive. Tangent would be y over x. Well, multiply top and bottom by 13. And you get 12 over 5 with a negative result, so negative 12/5. The rest is even simpler. Secant? Well, secant's the reciprocal of cos. Take cosine, flip it over. And briefly, I'm sure I've mentioned this already to you. I hope you're not bothered by the fact that I put the negative with the 13 instead of with the 5. It can go wherever I want. What is the cosecant of the angle? Well, it's the reciprocal of sine, which would be 13 over 12. And what's the cotangent? It's the reciprocal of tangent, which is negative 5/12. The reciprocal of tangent is negative 5/12. Questions with that one? These are really simple if you know all of this. So is the point negative 3,8 on the unit circle? Well, the unit circle only goes out to 1, and there's no way we can have x coordinates that big. If you square x and square y, what do we get? Let's do that, because we're going to need to. This is equal to r squared. So I would like you to figure out for me what you get. I'm pretty sure it's 73. Seeing a couple people nod, which means r is root 73. So, look, x is -3, y is 8, r is root 73. This is all the information you need to answer this question, because cosine is x over r. So it's -3 over root 73. Sine is y over r. It's 8 over root 73. Tan is y over x, which is going to be 8 over -3. And I just prefer to put the negative on the top. The three reciprocal trig ratios, well, flip those three things over and you have their corresponding partners in trigonometry called the reciprocal ratios. This would be root 73 over 3, and it's negative, of course. When you take a reciprocal of a negative, it doesn't change to positive, it just flips over. This would be the reciprocal of sine, this is the reciprocal of tan. And we do not need to rationalize these over root 73s. Sometimes on a diploma exam, you will see that as an answer. So if you want to, we would multiply top and bottom by root 73 and get 8 root 73 over 73. What mathematical genius decided that that's simpler than 8 over root 73? I don't know, because it doesn't look simpler to me. It's always been my argument for we shouldn't have to rationalize the denominator, because it doesn't always make things nicer. Any questions with 4? Okay, angle B lies in quadrant 2, and cotangent of theta is -2/3. Okay. You have done problems like this in Math 20, but of course it wasn't cotan. We know that cotangent of theta is x over y. Well, let me explain how I know that. I know that tangent is y over x, and cotangent is the reciprocal of it. So, and this is very important that you pay careful attention to this, because you know about every week in this class I say there's this thing that you're going to stumble on an exam. You're going to make that mistake. It's a popular mistake. You have to decide if x over y is -2/3. Look where they put that negative. And quite frankly, it doesn't matter where they put it. You have to decide where that negative goes. Is it with the x or with the y? And the key to that is reading that it's in quadrant 2. So in quadrant 2, over here, x is negative and y is positive. So that means x is -2, y is +3, and r is the square root of x squared plus y squared, which I'm going to ask you to find for me. I don't want you to find the square root of it. I just want you to find what number it is before you square root it. Is it 13? No. So you get 13. So r is root 13. Well, we're done. I mean, we're not done, but do you see what we have to do now? You have to formally write down now x over r and y over r and all those things. Incidentally, tangent, I'm not even going to look at x, y, and r. I'm just going to write -3/2 because it's the reciprocal of cotangent. So cosine is -2 over root 13. Secant's the reciprocal of that. Sine is y over r. Cosecant is the reciprocal of sine, so it's root 13 over 3, and we're done. The level of the work that you do on paper is so minimal because you're just using these 6 trigonometric ratio definitions. But you do have to think carefully about the quadrants. One final example. Secant of theta is 7 over 5. Cotangent of theta is negative. What's cosecant of theta? So, had you walked into the class at the beginning of the class and I showed you that question, you wouldn't have understood any of it. But this is a question that you would have been given possibly in Math 20, except you wouldn't have been told reciprocal trig ratios. So the first thing to note is secant of theta is r over x. And I always have to think about that every time. This isn't as obvious to me as what's 2 times 7. Well, it's 14. I don't even think about it. I'm on autopilot. I have to say, what is secant the reciprocal of? And I know that it's the reciprocal of cosine because I can go to my formula sheet. But secant and cosine are reciprocals. Okay. Just a note for me. So that means that since secant is 7 over 5, I can associate r with 7 and x with 5. And there aren't any negatives to deal with here. So I know x is 5, r is 7. If I want to find cosecant, let's see. Cosecant is the reciprocal of sine, and sine is y over r. So cosecant is r over y. So I need to know y, and then I have the answer to the question. So how do I do that? Well, I use x squared plus y squared equals, what's wrong with what I've just written? Evan? That's true. I don't know if y is positive or negative, but in terms of what I just wrote below on the bottom left of the screen, Zevi, r isn't 1. I mean, at least I don't know if it's 1. There is no way it's 1 because if you have an x-coordinate of 5, it's past the radius of the unit circle. So I guess I do. So what do we have here? We have 5 squared plus, and then we're going to take into account what Evan said about we don't know if y is positive or negative. We'll have y squared equals 7 squared. I hope you're okay with me, even though I say I always put brackets around things you square. We don't need brackets here, do we? You're going to take 49 minus 25, 24. So r is, or y is plus or minus root 24. We have to do our Math 20-1 due diligence here of breaking up radicals into simpler forms if we can. 24 is divisible by 4. 4 and 6 multiply to give 24. And the reason I chose 4 is a perfect square, which means the square root of 4 is exactly 2. So rather than saying y equals root 24, I can say 2 root 6. Or negative 2 root 6. And now, I mean, Evan was just one step ahead of us in terms of we don't know whether y is positive or negative. Now we're going to use that. That question of Evan's is we don't know. Well, how can we decide? Is it both? Is this an or case where we mean both? Well, it says cotangent. Oh, man. Cotangent is negative. What does that mean? If cotangent of theta is a negative number, I'm just going to write it that way, then that means x over y is negative. And that means one of two things. X is positive and y is negative, or x is negative and y is positive. It's one of those two. And it can't be both, because in the question, secant is a positive number. And secant's related to x. So because secant is positive, x is positive, and if x is positive, the only way for x over y to be negative is if y is in fact negative. So what this extra information in the question is telling you, what this is telling you is essentially it's in quadrant 4. It's giving you a hint as to which quadrant it's in. Because in quadrant 4, cotangent is negative and secant is positive. So it is this. Negative 2 root 6. What were we asked for? Cosecant, which is R7 over negative 2 root 6. And I'm going to throw the negative on top, which is where I like to put it. A couple of things. I guess first, any questions with that one? There's not a lot of work here. Mathematically, you got to square some things and subtract and simplify a radical, but there's a lot of thinking. So one of the things I want to point out to you is that you remember, how many of you last year used the cast rule? Where in this quadrant only cosine is positive, they're all positive, only sine, only tangent. There's no rule when we include all of this, other than for you to remember, if cosine is positive, then secant is positive. Okay. I guess you can still use it. The other thing I want to point out to you is when we say cosecant of theta is the reciprocal of sine of theta, that also means sine of theta is the reciprocal of cosecant of theta. A reciprocal mathematical operation is the only operation that keeps undoing itself. Take any number, take the reciprocal of it, take the reciprocal of that, you're back to the same number. Nothing else does that in the mathematical universe. Squaring, square a number, square it again, do you get back to the beginning? No. So sometimes you may need to look at it this way. It's a lot to take in Monday morning, but on page 201 of your textbook, you can do every second letter in questions 1 to 2. Do number 8 as well. And then there's, I think, 5 multiple choice style questions in your handout to give you a bit of practice with this. It's all relying on this additional information here that you're looking at on the left of cosecant, secant, and cotangent, along with what you learned in Math 20 about x, y, and r. Okay? Is that okay?